Hi, you guys, vlogging with vlog. Okay, so I am using Miss Miller's notes today because I realized that the very first day of this acid base unit, I usually do a lot of demos and I just write everything on the board. So we're just gonna kind of scroll through some definitions today, and then I think next time I see you, we'll talk about how we calculate things like pH and stuff. Um, I feel like it's been a long time, and so I'm trying to remember like what we've talked about. I think back in our compounds unit, we talked about how ionic compounds conduct electricity because they dissociate, which means they split apart. And then I think I briefly mentioned how there is one type of covalent compound that also conducts electricity, but it's because they do something different when we put them in water. They don't dissociate. And so this first day is usually just kind of focused on the differences between dissociating and ionizing. And then what makes something strong and weak when we use that term in chemistry, as well as what makes something an acid and what makes something a base. And so usually this last unit would be about 2 weeks long because there's a ton of definitions. I'm sorry, not a ton. We would have gone through 3 definitions of what an acid and a base is. But the most basic type of definition that we have is called the Ionize definition of an acid. And anything that forms, I have written on here hydrogen ions, but I'll clarify that in a little bit. They're actually called hydronium ions, and I'll show you why. But anything that makes H pluses when we put them in water, we call that an acid. So one of the ions that gets formed is an H plus. It's an acid. A base, by definition, is anything that increases the amount of OH minuses in water. So acids make H's, bases make OHs. And if you kind of think about things that you may see around you that have acids or acidic properties in them, all that means is that they make H pluses in water. And how much they do that reaction to form those H pluses tells us how strong they are. So if you think of, we eat like lemon juice. If you were on Zoom, I don't know if it was on the video, but when my husband left that 12-pack of Coca-Cola and it all exploded in the car, acids typically will corrode or eat away at metals. Bases usually don't. Acids usually taste sour, so then in class I would tell you a lot of puke stories where, you know how after you throw up, it tastes like just sour and it smells sour and it's just gross and it burns. That's an acid burn that's happening. Hopefully that's not happening to any of you right now. I'm trying to think. Acids like to react with bases, so we'll look at that reaction this unit. If you think of some acids, I know we talked about them. If I just start writing stuff out, I know hydrochloric acid, that's your stomach acid. Phosphoric acid is in Coca-Cola. I don't remember the formula for citric acid, but we used acetic acid. There's the formula for it. I just want us to notice that they all start with H's usually, to let us know that that's the H that's gonna come off to make the H plus ion. Bases are here: sodium hydroxide, potassium hydroxide, cesium hydroxide. We can come off with a list. I just want us to notice again the OH that's there. Bases usually taste really bitter. So if any of you, when you were little, had your parents like clean your mouth out with soap or something, if you said a bad word, that like a bitter type of flavor, that comes from bases. Otherwise, I'm going to say a lot of cleaning products are basic. Y'all are basic too, but whatever. So what makes something conduct electricity? There's 2 things. It's the idea that something forms ions in water, so it could either dissociate or it can ionize. Let's just review what dissociating is. Ionic compounds, anything that starts with a metal in it dissociates, so that means that it just simply splits apart into the ions that make it up. So I'm going to write that out. And so it would conduct. So I'd sit there with that sketchy light bulb and I'd put it in the water and I'd put that stuff in water. I'm right, we'd have calcium nitrate and we would form two separate nitrate ions because we'd make the ions that form that compound. Whereas here, this guy is covalent and it's not an acid because it doesn't start with H, so we don't need to worry about it conducting. It just simply dissolves. So I'm gonna write aqueous in really good handwriting. Things that are strong, all of them do this reaction. So if I were to put 100 units of sodium hydroxide in water, all 100 of them would split apart to exist as these ions. So what's funny is when you put sodium hydroxide in water, you actually don't have any sodium hydroxide solids stuck together. That whole aqueous solution is just sodium and hydroxide ions all floating around. Anything that's weak, only a few actually do that. So if we kind of compare these two pictures, strong things all exist kind of split apart. Weak things, only a couple of those molecules will split apart. So one thing I want us just to know is that anything that's strong are ionic compounds. All of the ionic compounds are by definition strong because when we put all ionic compounds in water, they break apart, they dissociate. I'm also going to put on here what we call strong acids. And we'll look at those. So hydrochloric acid is one of them, sulfuric acid is one of them, nitric acid is one of them, hydroiodic acid is another of them. I'm forgetting, I think two. I believe there's 6 strong acids, so I might kind of come back to that. But every other type of acid is weak. So acetic acid that we used in our burning down the house lab is a weak acid. So if I were to put 100 molecules of acetic acid in water, only like 5 actually make ions. So we know that ionic compounds dissociate, acids ionize. And what that means is that if I take hydrochloric acid and I put it in water, so I'm writing a plus sign, which I wasn't doing for the ionic compounds. When I take hydrochloric acid, it actually reacts with the water. That's ionization. It is reacting to form the ions, where dissociation is just splitting apart. So what we end up getting is we end up with H3O+. And we call that hydronium. And the other ion that's left over is Cl-. So I'm going to write aqueous. You see how it's kind of long? It's a lot to kind of write out. If you Google like hydrochloric acid reactions in water, they'll shorten it and they will write HCl makes this and this. So you might see that in some of the videos later on, but I want you to be very clear, acids don't actually do that. I've written it so it looks like it's dissociating. Acids actually ionize. We're just too lazy to write the water. So we're showing that that H is coming off. HCl is a strong acid, so that means all of this exists as H plus and Cl minus. So if I put 100 molecules of HCl in water, none of them will be left. They will all turn into these 2 ions. I just did this. So if I were to write the ionization for HCl, I'll just rewrite it for you. Again, ionization is when an acid reacts with water, we end up with H3O+ and Cl-, and I'm using a one-sided arrow because this guy is strong. I'm sorry, HCl is strong. So all of it reacts with water to make the ions. So technically, like if I were to ask you what's in the beaker, you wouldn't say HCl because all of that reacted. But this guy's weak. So when I show its ionization reaction, it's still reacting with water, but I use a double-sided arrow. And I'm going to write that we still form that hydronium, that H+, but the other ion that's left over is the acetate ion, so this guy, and I'm writing aqueous and aqueous. I just want to point out that I use that double-sided arrow because if I asked you, hey, what's in the water, you would also list this guy because hardly any of it broke apart. So which one would conduct electricity better if we had the same amount the same molarity of acid, HCl would. Why? Because it'll make more ions, because it's strong. Strong things, all of them form ions. I'm going to write HCl, and I'm also going to write HCl. I would have done this in front of you, and we would have gone, oh, wow, magical. So if we practice this, just to be clear, our big goal today was to get ionization and dissociation down. NaCl, it's ionic. All ionic things dissociate, so I'm going to circle them. H3PO4, do you see how it starts with an H? It's an acid. Acids ionize. Barium hydroxide, it's a base because it'll make OHs in water, but I want to point out it's ionic. All ionic things dissociate. HNO3 is an acid. Acids ionize. They react with water to make ions. This guy is ethanol. Doesn't do anything. It's just a covalent molecule. Wanted to point that out. Even though it's got that OH, it's not actually a base. It has to be ionic to make the OH ion. KOH is ionic. It's a base because it makes OHs. I'm going to circle it because it dissociates. And then HCl is an acid, so I'm putting an X or a box around it. And then CO2 is neither. It's not ionic. It's covalent and it won't ionize or dissociate, so I'm just going to kind of leave it. All the ones that are strong, all ionic compounds. So I'm going to underline every ionic compound that we have. And then the strong acids. So there were 4 that I listed off. Those are probably the more common 4. So I'm going to go strong acid, strong acid. So today, again, acids ionize. They start with H. They taste sour. Bases make OHs, so they'd have to be ionic in order to dissociate to form that. Peace, you guys.